PhDizzle, and I'm your host, Alice Cheng. And today we're interviewing J.R. Skok, who got his PhD in planetary sciences from Brown University and is now a Mars researcher at the SETI Institute. I'd love to hear about what you're doing and how you got involved, like how you were interested in space.
Yeah, I've always been interested in space. From the time I was like 3-4 years old, my mother painted glow-in-the-dark stars on my ceiling, so I've been watching the stars every night from a kid. And I kept doing that, just loved astronomy, loved space. I was lucky enough to work at an observatory all throughout high school. And then in high school I had a chance to start doing actual research, and I wanted to pick the right piece of astronomy to study. And I wanted something that was both real, someplace I could like dream of going, hold in my hands, but yet still be far enough away to be interesting. And Mars was that perfect like middle ground, like far enough away that like it was interesting, exotic, but close enough I could dream of going there. I could hold rocks from Mars in my hands. It was a real place, and so I was like, why Mars became the place. So I studied all throughout high school, doing research like independently with some classes and a few advisors. And then in colleges I went to Cornell University, and at the time in 2003 they were running the Mars exploration rovers with NASA. So I joined in with them, I worked all the color cameras, took images, and spent my undergrad years working with NASA to create beautiful color images of Mars and just loving the geology. Wow. So I realized that Mars is not an astronomy topic but a geology, and it's a geologic stories that we're trying to investigate. So that kind of led to what I'm doing now.
So here we're at Chabot Science and Space Museum. What's this thing behind us?
This is a telescope dome. So right now they're looking at the Venus, one of the morning and the evening star. It's because of its like placed closer to the sun than Earth. You can see it during the daytime at times like this. So it's one of the few objects bright enough to actually see during the daytime.
How do you make telescopes that can see so far?
So the key is with the size of our eye, that's always our limiting factor for what we can see. We need to collect photons. So the brighter something is, the more photons it gives off, and it's easier to see. If you start getting far away, very dim, it has less photons that reach you, so you need telescopes to basically collect as many photons as you can and condense them down so you can see, or they can go to your camera. And so the bigger the telescope, the larger the aperture, the deeper you can see, farther back in time, farther away you can see.
Okay. Right now we're at Mars. Can you tell us a little bit about this planet?
The fourth planet from the sun. You can shoot lasers at Mars to actually know how high everything is.
Wow.
They projected the height of volcanoes, of impact craters, of canyons. So here we see the Tharsis region. This is one of the youngest, largest volcanic regions on Mars. One of the biggest volcanoes in the world are here. And just a really cool place. Just because of the size of this pressure, it's opened up the largest canyon in the world. So if America is put on here, this is kind of LA, this is New York City. So this is basically the size of America.
It's like the Grand Canyon of Mars.
Yeah, so Grand Canyon is about like this thing here, that's like the Grand Canyon. It's like the Grand Canyon on this scale would just swallow up the Grand Canyon.
Oh my god. And is this the planet that's most like Earth?
The surface is most like Earth. It's much smaller than Earth, so it's about 1/3 the size.
Okay.
It has very little atmosphere, but just geologically. It has volcanoes, it has rivers, it has deltas, all the things, the geology we see on Earth, we see on Mars.
Okay.
Other places like Venus are closer as far as size and nearer to the sun, but the atmosphere, the surface environment is much more different. So if you're sitting on the surface, Mars looks kind of like you'd go to the deserts of Hawaii or Antarctica or Iceland, and you wouldn't notice too much of a difference just looking out.
Right. And you were doing some work on Mars, but not on Mars in grad school?
Yeah.
Where's that on here?
So I was part of the CRISM instrument. It was the satellite that looked at the composition of the entire planet.
Okay.
So I looked at a number of different places, different craters. So some of the craters are here. I looked at central peaks. And one of the problems on Earth, you want to see deep rocks. Deep rocks will show you how the planet was made. On Mars, there's no mountains that really create and bring up old rocks. So we use impact craters to kind of probe deep.
What's an impact crater?
So all these little holes here, these are places where asteroids have slammed into the surface, inject material. And so we have rocks from Mars on Earth already. And these are rocks that these impacts created and put us into space, and very few of them come to Earth and are found. And so we know have rocks from Mars that originated there and were ejected out of the past. When you're looking at composition, you want to find the darkest places possible, because the worst part for composition is dust. There's so much dust on Mars, and it blocks your view of the surface. So here, this is a Sirius Major volcano. You can see it's kind of very dark. And the darkness is here is because all the wind has blown off the dust. And that means we can actually know what the composition is. So for my work, I spent a lot of time understanding the volcano composition, how it evolved, how it grew. And I actually found some ancient hot springs, silica deposits, just like we found in Iceland or Yellowstone. There's nice little hot spring deposits found right in the caldera here.
Okay.
And hot springs are really great on Earth because it's a perfect place for life to kind of live and develop and be preserved. So these hot spring areas, there's 2 places on Mars here and Gustav Crater on the other side have silica deposits that we think were hot springs at one time.
Wow.
So now NASA's trying hard to develop missions to go to these places to look for evidence of life. So that's my job right now, is to understand hot springs all around the world to figure out how to actually study them on Mars to find evidence of ancient life.
Is there water on Mars? Can we support life?
Yeah, there's lots of water, but water in ice form. So the poles, they both have like huge layers of ice, and there's buried ice all through the pole region. So if you go just under the surface in the north, there's lots and lots of ice and water there. Also, the entire, like, see this kind of bumpy area? This is Southern Highlands, and these are just full of clays. So clay minerals are just full of molecular water. So there's molecular water, there's frozen water, there's water in the atmosphere. The one thing that Mars does not have on the surface, at least, is liquid water. There still might be liquid water deep in Mars, but that's a very hard thing to access right now.
Okay. So Mars has a North Pole and a South Pole. Does Santa also go to Mars to deliver presents?
So far, there's no kids there, yeah. So,
Okay.
So hopefully someday, though, we'll have families,
But
kids.
if we move there?
If we move there, yeah, then we'll have everything we
Well, where would he get the presents from?
Yeah, it's a long trip taking the presents from Earth all the way to Mars. That's a long journey and hard to do on a single day. But it turns out that Mars is a very dynamic planet made of different minerals, and everything that we need, we're going to have to be able to make from what's there. And using technologies we're already starting to develop here, we can turn the geologic materials of Mars into most of the things we need.
Oh my God.
The volcanic rocks, the same rocks that make up the Tharsis region here, they can be melted down, pulled into threads, and woven into fabrics. So everything that we use in fabrics, from clothes to luggage, can be made from these type of rocks.
And how would you get access to those rocks to start making those things?
So, Mars is just a planet, just like Earth. So a lot of the same minerals that we find on Mars, we already have on Earth. So the same rocks that make up these volcanoes, we find in Hawaii, we find in Iceland, we find around the world. So we can practice using the same type of rocks, the same minerals here, get all the technology going, make products that we want to have in our life, learn how to do that. And then once we can actually get the rockets to go to Mars, we'll know exactly how to do it. Just pack up the factory, send it to Mars, and start producing the stuff of civilization on the surface there.
So you're going to be a Mars entrepreneur.
Hopefully,
That sounds so cool. Do you have a name for your company?
Yes, it's called Made of Mars. Our future will be made of Mars.
PhDizzle.
Having fun with smart people who do cool things.
Yes.